Okay, guys, in this section we're talking about polynomials. The goals in this section, we want to identify the degree, leading term, and leading coefficient of a polynomial. And that's number one. Goal number two, we want to add and subtract polynomials. So what's a polynomial? Let's start first with the definition of a monomial. A monomial is a constant or a product of constants of a constant and variables raised to whole numbered exponents. Okay, that sounds kind of like Greek to me. So what's a constant? I don't know, the number 5 is a constant. The number pi is a constant. So 5, the number pi, negative 1,000, those are all monomials. However, they're not very interesting monomials. We could also form a monomial by multiplying 5 times x squared. Also, we could have other variables, y cubed times y cubed times z. So a monomial, we normally think of it as a product of perhaps a constant. Well, it's always a constant. If you didn't see a 5 there, if you didn't see a number there, you could think of 1 as being the coefficient out front, right? So a monomial is a single term, and what we mean by that is it's a product of a variable, a constant, or a variable or variables brought to whole numbered exponents. So you're not going to see fractions in the exponents. You're not going to see square roots around x or y or z. You're not going to see square roots around variables, in other words. And then what is a polynomial? Well, a polynomial is just a sum or a difference of monomials. So for example, a polynomial is a monomial. So you could take xy squared. A polynomial is, or a monomial is a polynomial with one term. So technically a monomial is a polynomial, but not necessarily vice versa. You could have something like x squared plus 7x plus 12. That's actually called a trinomial. Any guesses as to why? Because there's 3 terms, right? Can you identify the terms? Yeah, what if I change it to a minus 7x? Then what would you call the terms? The terms or individual monomials that make this up, this middle one up, the terms would be x squared. You'd include the negative, wouldn't you? You'd think of it as plus a negative 7x when it's a minus 7x. So you'd include the negative on the 7x. So the individual monomials that make this polynomial up, x squared minus 7x plus 12, are x squared, negative 7x, and 12. And then, of course, you could have a polynomial with many different variables. You could have something like negative 2.5 x squared y to the 6th minus z to the 5th plus xz squared. Just making them up as I go. But here's a polynomial of 3 variables, right? So what's the degree of a polynomial? I'm going to give you 2 examples. They're both going to be monomials. Okay, so in part A, I'll give you one you might already know. What's the degree of 5x to the 12th? First of all, is it a monomial? Yes, it's a product of a constant 5 and a variable, single variable brought to a whole numbered exponent. It's definitely a monomial. What's the degree? 12. Okay. Now, contrast that with a monomial with more than one term. I'm sorry, excuse me. A monomial with more than one variable. A monomial can't have more than one term. So how about negative 1.2 x squared y to the 5th z? I haven't told you how to get the degree of this one. To get the degree when it has more than one variable, you add the exponents on the variables together. So if you had like negative 1.2 cubed, you don't look at that. The constant, it doesn't, because you could take negative 1.2, cube it, and write that number instead. So you don't look at if there's an exponent on the coefficient in front, you don't look at that exponent. But the degree, what's the exponent on the z? 1. So the degree, if the monomial, if it has more than one exponent, the degree is going to equal the sum. So it's going to be 2 plus 5 plus 1, which is 8. The degree of this guy is 8. That's probably something you haven't seen before. It's not complicated, but it's just new. So anything new I want to take a little more time on. So then what's the degree of the polynomial that has more than one term? Well, this next example will show us. Determine the degree of each term and the degree of the polynomial. So let's make sure you know what I mean by terms. Let's name the terms here. The terms are the little products that we're adding or subtracting. And actually, if you're subtracting, you include the negative. So it's really just addition. So what are the terms? Just going from left to right, what are the terms? I'll get you started. 5c to the 11th power. Comma, 12c to the 12th, t to the 9th. What's the next one? 5c to the 5th, t to the 5th. The next one? 7c to the 5th. The next one? You actually include the negative, so if you see a minus term, you include the negative with it. So it's -9. So those are the terms. Now the degree of any term, if the term just has one variable in it, then the degree is just going to be the exponent on that variable. So the degrees, we're going to list the degrees, the individual degrees below the term. So the degree of 5c to the 11th is 11. But if it has more than one variable, that second term has a c and a t in it. To get the degree of that term, you're going to add the exponents together. So 12 plus 9, 21. The degree of that second term is 21. What's the degree of the third term? You see c to the 5th, t to the 5th, you add the exponents to get 10. What's the degree of just 7c to the 5th, this second to last term? Just 5. Just because there is no second exponent to add it to. What do you think the degree of a constant term is? No, 0. The degree of something like t to the t, if you had like a plus t somewhere in here, then there's a hidden exponent of 1 there. The degree of that term would be 1. Okay. So those are the degrees of the individual monomials or terms which make up the polynomial. The highest one you see is the degree of the entire polynomial. So the degree of the entire polynomial, I'll say poly for short. Which one's the highest? 21.